So, you want to build a crypto mining rig. Awesome. Let me make you a promise right now. By the time you finish this guide, you will have a fully functional 6 GPU mining rig up and running. This isn't some high-level theoretical discussion filled with jargon you won't understand. This is a practical, step-by-step walkthrough designed for today, in 2026. I'm going to take you from a pile of boxes to a machine that generates cryptocurrency. No prior experience is needed, just a willingness to follow instructions carefully and a bit of patience. We'll go through each component, each screw, each software setting together. It's a rewarding project, and I'm here to make sure you succeed. Right, let's move on. The process might look intimidating at first, with all the components and cables, but I've broken it down into simple, manageable chapters. You might be wondering, why 6 GPUs? Why not start with 1, or go all out with 12? The 6 GPU configuration is the sweet spot for beginners in 2026, and it strikes a perfect balance between several key factors: earning potential, initial cost, complexity, scalability. A single GPU just won't generate enough revenue to be exciting or to offset its own electricity costs in most places. A 6 GPU rig, on the other hand, has enough combined hashing power to provide a noticeable return, making the whole endeavor feel worthwhile from the get-go. It's the point where this hobby starts to pay for itself and then some, which is the goal for most people getting into this space. Most consumer-grade motherboards designed for gaming come with enough PCIe slots to handle this many cards with the help of risers. This means you don't need server-grade hardware. A single motherboard, a single CPU, and a single stick of RAM can run all 6 GPUs, keeping costs low. A 6 GPU rig fits in a spare room, a garage, or a well-ventilated basement. Once you've built and stabilized your first rig, scaling is as simple as building another identical one. Alright, let's get to the fun part, the shopping list. Getting the right components is crucial. Don't worry, I'll give recommendations and alternatives. You don't need the absolutely most expensive parts for everything. The GPUs are the stars of the show. For other components, reliability beats raw performance. Here's what you'll need: motherboard, CPU, RAM, SSD, PSU, 6 GPUs, PCIe risers, open-air frame. Choose 6 identical GPU models if possible. Check profitability charts online. Look at current generation NVIDIA cards. Look at current generation AMD cards. Get a mining-specific board or a gaming board with at least 6 PCIe slots. Use an entry-level Intel i3 or AMD Ryzen 3. One 8GB stick of DDR4 or DDR5. Storage, 120 to 250 GB SSD or a large USB 3.0 for Hive OS. High-quality PSUs, 80 plus gold or platinum. Plan roughly 1,200W to 2,000W depending on GPUs or 2 850W units. Get 6 PCIe risers and a sturdy 6 GPU open-air frame. Power cables, zip ties, Phillips screwdriver, anti-static strap. Software: Windows 11 works. Hive OS is highly recommended. Miner options: T-Rex, NB Miner, or Team Red Miner. Before you touch a single component, we need to have a serious talk about safety. We are working with electricity, and the combined power draw of a mining rig is significant. The number one rule is to build your rig with the power supply completely unplugged from the wall. Only plug it in when I specifically tell you to for testing purposes. You should also work on a non-conductive surface, wood or plastic, never carpet. Static electricity is the silent killer of computer components. Use an anti-static wrist strap, clip to unpainted metal. Wear it snugly. This grounds you and discharges static. If you don't have one, frequently touch a grounded metal object. A 6 GPU rig can draw over 1,000 watts. Most 15A home circuits safely provide about 1,440W continuous. Confirm your circuit rating and avoid sharing with high-draw appliances. Place the rig in a cool, well-ventilated area. Keep it clean, dry, and far from liquids. During the first days, don't leave it unattended for long. Monitor temps and operation. Taking these safety precautions seriously will keep your build smooth and your long-term operation secure. With the safety briefing out of the way, let's prepare our tools and workspace. You don't need a professional workshop. A sturdy dining table or a workbench will do just fine. Clear the surface and give it a quick wipe down. Lay out a large, non-static mat if you have one. Open boxes carefully and keep screws and small parts organized in labeled trays or cups. A magnetic parts tray is fantastic. Your primary tool is a good Phillips screwdriver, wire cutters or strong scissors for zip ties. Zip ties. Optional, a multimeter. Review the manuals for your motherboard and PSU. They show CPU power, front panel pins, RAM placement, and which modular cables are CPU versus PCIe. Plugging the wrong cable can cause serious damage. Once prepped, lay out the open-air frame, place the motherboard on its anti-static bag, and unpack the CPU, RAM, and SSD, but keep them protected until install time. This methodical approach keeps everything safe and accounted for. A little organization now saves a massive headache later. Now that our workspace is set up like an operating room, we're ready for surgery. It's time to start building. The first step is to assemble the skeleton of our rig, the open-air frame. Follow the instructions, then place it on your work table. Next, we'll install the motherboard. Your frame includes standoffs. They keep the board from touching metal and prevent catastrophic shorts. Screw standoffs into the tray holes that align with your board. Place the motherboard and secure it snugly. Open the socket lever. Align the triangle on the CPU to the socket mark and let it drop in with zero force. Close and lock the lever. Open the DIMM clips, align the notch, and press firmly until it clicks and locks. Install your M.2 SSD in its slot or mount a 2.5-inch SSD to the frame with screws. Mount 1 or 2 PSUs to the frame and secure them firmly. Route and plug the 24-pin ATX into the motherboard and the 8-pin EPS into the CPU power port. Leave other PSU cables aside for now. Motherboard, CPU, RAM, storage, and main power, done. Section 7. Powering the Beast. Installing risers and GPUs. Now we're ready to install the components that do all the heavy lifting, the GPUs. A riser kit has 3 parts. A small PCIe X1 card for the motherboard, a larger X16 slot for the GPU, and a USB 3.0 cable connecting them. Plug a small X1 card into each of 6 PCIe slots. It's easier before GPUs are in the way. Each GPU's gold connector slides into a riser X16 slot. Make sure it's seated firmly. Place assemblies on the top bar and secure brackets with screws. Space them evenly for airflow. Connect USB cables from riser boards to the small X1 cards on the motherboard. Each GPU needs dedicated PCIe 6-pin or 8-pin power direct from the PSU. Never daisy chain one cable to power multiple high-power GPUs. Each riser also needs power, preferably a dedicated 6-pin PCIe or Molex from the PSU. Avoid SATA to 6-pin adapters. They can be a fire hazard. Bundle and route cables with zip ties away from fan intakes and hotspots. Double-check, 24-pin secure, CPU power plugged in, every GPU and riser powered. A thorough check now prevents headaches later. Section 8. The moment of truth. Powering on and first boot. All components are installed. Before you plug in, do one last visual inspection and remove any loose screws. Connect a monitor to the primary GPU or the motherboard's output if using integrated graphics. Plug in a keyboard. Plug the PSU into the wall, flip the switch on, then start the system with the board's power button, or briefly short the PWR-SW pins. Fans spin. A startup screen appears. Congratulations, your hardware is likely assembled correctly. If nothing happens, switch off the PSU and recheck the 24-pin and CPU power connections. On boot, tap Delete or F2 to enter BIOS, the motherboard's control panel. Confirm CPU model and RAM amount. Don't worry if all 6 GPUs aren't listed yet. Set boot device to your SSD or USB. Enable above 4G decoding or crypto mining mode. Set PCIe to Gen 1 or Gen 2 for riser stability. Disable unused onboard devices. Save and exit to apply settings and reboot. Huge milestone. Section 9, bringing it to life. Operating system and software setup. You have two main paths, Windows or a mining OS. For beginners, I strongly recommend Hive OS or Simple Mining OS, designed for mining, easy setup, drivers and miners included, web dashboard for PC or phone. Download the image, use Balena Etcher, flash to SSD or USB 3.0. Create an account, generate rig config, copy it to the drive, plug into the rig, and boot. It will connect to your online dashboard, list all GPUs, let you set wallet, coin, and pool. Prefer Windows? Boot from a Windows USB, then install correct NVIDIA or AMD drivers from their official websites. Set power plan to high performance and disable automatic restarts. Download T-Rex or NB Miner for NVIDIA, Team Red Miner for AMD. Extract zip, edit.bat or .conf with your wallet and pool server. Double-click the miner to start. Pools combine your hash rate with others for steady payouts. You're now mining. The final polish: tuning, troubleshooting, and maintenance. You did it! Your rig is built, software installed, it's hashing away. But we're not quite done. Tune for the best balance of hash rate, power consumption, and temperature. Not max performance at any cost. Use MSI Afterburner on Windows or Hive OS overclocking panel. Adjust core clock, memory clock, and power limit. Lower core, raise memory, reduce power limit. Start conservatively. Lower power to 70–80%. Increase memory in plus 25 to plus 150 MHz steps. Let it run and watch for invalid shares. If unstable, back down to last stable settings. Record your stable tune. If it won't boot, recheck power. If a GPU isn't detected, swap risers. If miners crash, ease memory core clocks. If temps exceed 75–80 degrees C, add fans or increase spacing. Every month or two, shut down, unplug, and clean dust with compressed air. Set up alerts in Hive OS. With proper tuning and cleaning, your 6-GPU rig will be a reliable workhorse, earning you crypto for years to come. Enjoying this build? Smash like, hit subscribe, and ring the bell for weekly mining guides and rig upgrades. Drop questions below. See you in the next video.